So until recently, we have been learning about software development lifecycle, going from requirement elicitation to designing to development, testing, deployment, and all the way down to maintenance. We've been learning about the traditional waterfall model, the new agile methodology, and iterative model of software development. Now, every organization these days is trying to incorporate AI or ML into their product. And this new requirement of building ML based system because of the whole decision automation boom, this has given rise to a new ecosystem, a new engineering discipline, which is called MLOps. So hello everyone, in this video we are going to defragment what is MLOps, what are the key challenges it addresses, what does it consist of, and what all skills and what all combinations and profiles one must target in order to get started with it. So this is a fairly new term that has popped up, which is creating a lot of buzz. And it is also giving rise to new job profiles as well. So MLOps is basically short for machine learning operations, or some people refer to it as model ops. Now, looking it up on Google Trends will tell you that it is a relatively new discipline as more and more organizations are trying to integrate ML into their products and platforms. Now, if I had to define it, this is how I would define it. So, it is an engineering discipline that aims to unify machine learning systems development, which is the dev part of it, and machine learning systems deployment, which is the ops part of it, in order to standardize and streamline the continuous delivery of high performing models in production. Let's talk about why do we need MLOps. Now, until recently, we have been dealing with manageable amounts of data and a very small number of models at a very small scale. But the tables are turning now. We are trying to embed decision automation across a wide range of applications and in all aspects of an application. So this basically gives rise to a lot of technical challenges with regards to monitoring the performance of such models, data governance, model governance, and the risks involved with such ML based systems and going to production with them. So, in order to understand MLOps, we must first understand the machine learning lifecycle in itself. So, the life cycle involves a lot of different teams, from business development or product team that defines the business objectives, goals, along with the key performance indicators. Then we need data engineers who help with data acquisition and preparation. Then we need data scientists who architect the whole ML solution and develop those models. Then we need the IT team or the DevOps engineers who completely set up the entire deployment process, and they help you monitor those models alongside the data scientists. Now, teams at Google have been doing a lot of research on such technical challenges that come from building ML systems. Neurup's paper on hidden technical debts in ML systems shows you that writing machine learning code or developing models is just a very small part of the whole process. You have to take care of the configurations, the tools, the processes that are to be integrated into the whole machine learning system. Now, to streamline this entire process and to have a coherent engineering culture across all the teams that are involved, we need MLOps. So, managing such systems at scale is not an easy task, and there are numerous bottlenecks that are to be taken care of. So, following are the major challenges that teams have been facing. So, first of all, there is a shortage of data scientists who can also write scalable web application. So this has given rise to a new profile, which is a machine learning engineer, which serves at the sweet spot of the intersection of data science and DevOps. Now, another challenge is reflecting the continuously evolving business objectives in the model. So, there are many dependencies. Your data is continuously changing. Then you have to maintain the performance standards of the model. And at the same time, you have to ensure that all the AI governance rules are in place. So it's hard to keep up with the continuously changing and evolving model, and then incorporating the changing business objectives as well. Then there is a communication gap between the technical teams and the business teams with limited technical expertise. They often find it very hard to communicate, and it also becomes the reason for the failure of very big projects. Then risk assessment is another challenge. Basically, often what happens is that machine learning models, they tend to drift away from what they were initially intended to do because of the new data coming in and many other biases that are being introduced into the system. So they are very sensitive to that part, and you have to ensure that you do a very meticulous analysis of the risk reward ratio and analysis of the entire system or the problem statement that you are trying to solve. For example, the cost of a wrong or an incorrect video recommendation on YouTube is very small as compared to the cost of flagging an innocent person for fraud, and you'd be declining their loan application, you'd be blocking their account. So the cost on that front is very high. Now let's talk about the major phases or the major stages involved in ML ops or the machine learning lifecycle. And another way to look at this section is what all skills should a machine learning engineer have. So first of all, you should know how to frame machine learning problems from the business objectives. So that is a very important skill. Often you would be given business objectives with certain key performance indicators that also drive the monitoring process once your model is deployed. So being able to define the machine learning problem is an important skill. So, for example, a common objective or a simple objective could be reducing the fraudulent transactions below 0.5%. Or it could be, the ability to detect skin cancer from certain images that are labeled by a dermatologist. Now, once your objectives and your problem is clearly defined, the second step is to architect machine learning and data solutions for your problem. So here you need to find out a relevant data source, if there is any available relevant data set. Then you have to check for the credibility of the data and its source, check if the data source is GDPR compliant and if the data is coming from the right source or not. Further on, you would need to develop data pipelines. So you have to check which all cloud services would you be using, then how to build a data pipeline, what all cleaning or formatting changes you would have to do, and then how many sources of data would the data be coming in from. Now, after that, the next step is data preparation and processing. So this is basically data engineering, where you have to do tasks like feature engineering, cleaning the data, taking care of any missing values, outliers, rebalancing, etc. And you have to design and code your data pipelines that would be processing your data, doing all of these steps, and will produce data that is compatible with the model. And these pipelines are to be deployed. So you first have to make sure that what sort of a data source are you dealing with. Is it like batch data or streaming data? And then use the right cloud services, like would you be building an AWS S3 data lake, or what sort of tools would you be using in order to develop those pipelines? Now, as soon as your data is prepared, the next step is to train your model. So you'll be starting off with a bunch of different types of model that would fit your problem statement, and then you will be narrowing down to the best solution. And in that process, you would be doing quantitative analysis as well as qualitative analysis. Quantitative is basically using evaluation metrics like accuracy, or if you're solving a classification problem like precision, recall, F1 score, so on and so forth. And for qualitative analysis, you would be using how explainable your model is, or what sort of mathematics drives your model. So In this process, you'll be running a lot of experiments. So the experimentation process is becomes difficult and challenging because when you have to ship your model for production purposes, there you kind of feel that the same model is not actually packaged, and for that, reproducibility is basically a very big concern. And now we have open source tools like DVC, where you can version control your data set, or continuous machine learning, which is CML tool, where you can write CI/CD pipelines and focus on writing unit test cases and so on and so forth to test your models. So you can incorporate these sort of tools to version control your models, your configuration, or if you want to go back to a previous configuration of a model, you can do that as well. So adding version control is a key step here. Then writing unit test cases and checking your model against baseline simpler models, checking them across different dimensions, and then finally scale your model for production purposes using distributed systems, hardware accelerators, and scalable analysis. The next stage is building and automating your ML pipelines. So here you would need to identify system requirements, which is compute requirements, parameters, triggers, so on and so forth, and then choose an appropriate cloud architecture. So it be hybrid or multi-cloud. Then construct training and serving pipeline, testing pipelines. Use CI/CD to deploy your models, to deploy your pipelines, and then track and audit your pipeline runs. And at the end, you should perform data validation. Now, after training your model, the next step is to deploy your models to production. So there are basically two types of deployment: static and dynamic. In static, you package your model and you send it as an installable application software, and both the application code as well as your model reside in the same package. Whereas in dynamic deployment, you basically deploy your model using some sort of web framework like Fast API or Flask, and here you serve it as an API endpoint to which users send requests. And in dynamic deployment, there are basically different types. So you can deploy using a server, deploy using a container, Docker or Kubernetes, and then serverless deployment. And then there is model streaming, in which instead of REST APIs, you all of the models and the application code is registered on a stream processing engine like Apache Spark or Storm or Apache Flink. And then basically there are a few considerations that you should make sure. And so these are ensuring proper documentation and testing, and really revalidating the model accuracy, performing explainability checks, ensuring all governance and requirements have been met, and then checking the quality of any data artifacts, and also at the end load testing, which is making sure the compute resources are sufficient. So once your models are deployed, the next step is to monitor, optimize, and maintain them. So here you're not only required to maintain the performance of the models, but you are also required to ensure that there is data governance and AI governance put in place. So when I say governance, I basically mean control measures that have been put in place to see if any parties, any stakeholder, user, or employees that are affected by the model are not treated unfairly. So as part of this phase, we need DevOps engineers and data scientists to do tasks like keeping track of performance degradation, business quality of the model predictions, setting up logging strategies, and establishing continuous evaluation metrics, troubleshooting systems failure, or if there is any introduction of bias, you address that as well. And then finally tune the model performance in both training as well as serving pipelines that are deployed in production. So that was all about MLOps, And I personally feel that if you're someone who comes from a software engineering background and who's also into data science and understand what machine learning is all about, then you probably would be a good fit for a position like machine learning engineer, who would understand the breadth of this whole ecosystem. And MLOps is an engineering culture in itself that affects several stakeholders in the team. So if you want to become an ML engineer, so following resources would basically help you out. So I've recommended this book before, as Andrei Burkov has done an amazing work yet again with his another book on machine learning engineering. So this is highly recommended. In this book, he has covered every minute detail of building machine learning models in production. So he also has another best-selling book, which is called the 100-page machine learning book for people who are new to machine learning, who are just getting started. And you can read this book for free, as he has provided the links to the release draft of the chapters below. So here are the links. Then there is another book which is called Introducing MLOps, that will walk you through what MLOps is all about, how it works, and explains every step of the life cycle with all technical details along with the real world examples. Now, if you're someone who already has a lot of experience in machine learning engineering or developing models for production, then you should look to get yourself certified. I mean, if you're looking for a job, then you can actually go for such certifications provided by major cloud platforms like Google Cloud and AWS. So, professional machine learning engineering is one such certification then that you can actually aim for. And another one is AWS machine learning specialty. So you can also try out a bunch of other around data engineering that is offered by AWS. Also, I'm planning to do a complete series of tutorials around machine learning engineering and building end-to-end machine learning systems, from framing the problem, going to deploying those machine learning models in cloud, and building data pipelines as well as ML pipelines. So yeah, consider following me on Medium, and I'd be also releasing videos of such tutorials. So yeah, you can consider subscribing if you want to watch more content of that sort. So I hope you learned something about MLOps in this video, and if you did, please give it a thumbs up. Share this video with all of your friends, engineers, analysts, scientists, and comment down below if you have any thoughts, concern, suggestions for future videos. And yeah, I'll catch you guys in the next one.